Welcome to lecture 9 part 2. Hopefully we are looking at a shorter video today because we just have 4 pages to fill in. So let's see how we can do some more examples on functions and their graphs. Now things you should know. Well, is it a function or not? That's the first question. So function or not. And as we might have learned in this class, a y squared is the turn off factor here. When you see a y squared, that means it's not a function. This is not necessarily true, but at this level you can just think of it as true. Okay, so y squared term that says not a function. Okay, so that should be enough criterion for you to determine whether whether a formula is a function or not. So now in the first one, you don't see a y squared, you see y equals x squared, and of course y equals x squared is a parabola where passing through 0. So this is not, this should be something like this, but anyways, it's a function. And y equals x squared plus 1, that would be the same parabola shifted one unit up, and that's also a function. Now this one right here, y squared equals x squared, that is not a function because you can see the y squared term, so not a function. So even if you have y to the power even as the largest factor, you can say that's not a function. If you're wondering how does this look like, it is, I think it's a hyperbola. It's not the 1 over x function, it's a little different. It's a hyperbola, that's what we call it. Okay. Oh well, probably might be something like this, but either way, it's not a function because for example, the value x equals 1 would correspond to y equals 1 and y equals -1. So the factor that determines that is the y squared term, so that's it. And here also, this is of course not a function. Again, you can see the y squared term, so not a function. And you can think about the shape. It's not a function, and of course it's a circle of radius 2. X squared plus y squared equals 4 is a circle of radius 2. And centered at 0, 0. So you know that from lecture, I guess it's 7. Okay, so either way, when you see a y squared, just you can just be sure that it's not a function. All right. So the next one, find all the zeros of the following function. All you have to do is set the function equal to 0 and solve that equation. So to find the 0, set the function. So we are not plugging in 0. Set the function equal to 0 and find x values or solve for x. Okay, so function equal to 0, so you get 0 equals x cubed minus 2x squared minus 4x plus 8. Now, well, it just as a ritualistic thing, I would have this on the left hand side. So x cubed minus 2x squared minus 4x plus 8 is equal to 0. And you can see that these factors, and you can use factor by grouping. Remember factor by grouping, you can see the common factor. Here you have x squared is common, and on the other term you can see 4 is common, but I would say -4 is common. Okay, so take the common factor out of two terms. You know how to do this. X squared, x minus 2, -4, x minus 2 equals 0. Negative 4 times negative 2 is plus 8. So that's the correct way to factor it. And now you can see that x minus 2 is a common factor. Common. So you can take it out, x minus 2, and then write down what's remaining. Here you have x squared. Write down what's remaining. Here you have minus 4 equals 0. Now you can factor this as difference of two squares. Now all these things we learned in factoring lesson, that's lecture 3. So you should be very familiar with these things. Now you have x minus 2, x minus 2, x plus 2 is equal to 0. So you get x equals 2 and x equals negative 2. Well, from here you get x equals 2. From here also you get x equals 2, and here you get x equals negative 2. Well, of course you can set each. So how does that work? You would set each factor to 0, but we have to always think about saving some time. So x minus 2 equals 0. Add 2 to both sides, you get x equals 2. X minus 2 equals 0. Add 2 to both sides, you get x equals 2. X plus 2 equals 0. Subtract 2 from both sides, you get x equals negative 2. So right now you should be able to look at these and mention where x equals 2 and x equals negative 2. That's it. Alright, let's move on to the next page. Now, when you have a rational function, remember this, it's quite important. We will do this formally when we talk about rational functions, but it's very important to remember. You take the function, reduce it, and set the top equal to 0. Okay, you don't set the bottom equal to 0 to find zeros. Let me write down that statement that I just said. So take the function, reduce it. Well, of course you need to find the domain, so that would be like the step 0. Find the domain and then reduce the function, and then find the zeros in the numerator only to find zeros. Okay, so if you ask me the question, why do you not consider the denominator? The denominator does not give zeros. The denominator gives something called vertical asymptotes. We will not talk about that today, but let me just write here the zeros of the denominator are vertical asymptotes. That's it. Okay, so right now we will not talk about that. We will talk about zeros, and then we will build up on that. Once we are familiar, we can go to vertical asymptotes, but right now just zeros. So remember that. So you would not equal this to 0, equal this to 0. No, you just equal the top equals 0. Okay, so right now you can see the function is already reduced. There's no crossing off, so it's already reduced. Okay, and then you set the numerator equal to 0. Okay, so you take it out. 1 minus 2x is equal to 0. Add 2x to both sides, you get 1 equals 2x, divide by 2, so you get x equals 1/2. At that point, just make sure is it in the domain. I just made that point that it's not important. It is important. So at that point, you need to check that whether it's in the domain. Okay, so let's see what's the domain. Now to find the domain, the denominator shouldn't be 0. Okay, for the domain, the denominator is not 0. So now we are not setting things to 0, we are setting things not equal 0. Okay, so you get 1 plus 3x not equal 0. So 3x not equals -1. So x not equals -1/3. Now anything not equals 1/3 is in the domain, or you can use interval notation to show that. That's that. Right? And the question is x equals 1/2 in the domain. Well, yes, it's not -1/3, so it's in the domain. So the only 0 is x equals 1/2. So let me just write it down in words. Only 0 is x equals 1/2. So you need to set the numerator equal to 0 and find it, but you will also have to find the domain. So the whole purpose of setting the denominator equals 0 here, not equals 0 here, is finding the domain. Okay, not finding zeros. All right. Okay, guys. So let's see that these ideas interplay big time in the example number 3. So we need to reduce this, which means we need to factor the denominator, and fx is equal to x minus 1 x plus 2. That's already factored. Let me factor this on a side, but at this point I should be allowed to factor. Just say factor this and factor. Well, let's see. X squared plus 3x minus 4. So factors of -4, that adds up to plus 3, where plus 4 minus 1. So because this is 1, we can use a shortcut, x plus 4, x minus 1. Remember how we did this in lecture 3. Okay, so you get x plus 4, x minus 1. Now you can find the domain. Remember, how do you work with rational expressions? You factor, find the domain, reduce. So this is from lecture 4. You factor, find the domain, reduce. Okay, so the factoring step is done. Find the domain. So this portion, the denominator, shouldn't be 0. Okay, so you get x plus 4 not equals 0. That would give you x not equals -4. Okay, and also x minus 1 not equals 0. So x not equals 1. So that is the domain. This is in the middle of the question, so I will not ask you to use interval notation, but if you want to, you should be able to do that. Okay, and then reduce. How do you reduce that? Let me just write down the function again and then write down the reduction. Reduction means just cross things off. So x plus 4, x minus 1, and just cross things off. So you get x plus 2 over x plus 4. Now you can find the zeros. Set the numerator equals 0. So you get x plus 2 equals 0, x equals -2. And the domain says x cannot be -4, x cannot be plus 1, but x equals -2 is fine in the domain. So therefore it's the only 0. Now what can go wrong here? Well, people will just assume that, well, if you remember my method halfway, find the zeros of the numerator. You will just find the zeros of the numerator, and that would be x equals 1 and x equals -2. But you should understand that it should be in the domain. So what can go wrong here? People finding zeros but not checking things in the domain. Alright guys, I believe it's time to go for a question. So you will see a question on the screen, and it is from factoring by grouping. So just if you're not sure about that, go back and see how do we do that, and then answer the question. Okay, I hope you got it right. And this is how you do it. It was exactly like the example number 1 we did. So you factor by grouping and you get this. You set it equal to 0 and you should get x equals plus or minus square root of 3 over 2. I did not rationalize the denominator because at this point I really don't care. But if it's in the multiple choice, you might have to rationalize the denominator. So that's what you have. Okay, let's move on. Now the next idea is the average rate of change. Now the idea of average rate of change is so important, so you might be tested on this. So the important is it's very related to calculus. Now this class is a pre-calculus class, so we need to do something that you would need in calculus, and one of those things is the average rate of change. And you need to remember the formula. The formula is average rate of change on an interval AB. Well, if you don't like formulas, you can remember an example. Either way, f of b minus f of a all over b minus a. Okay, so let's do this. So all you need to do is plug things into a formula. It can't get any easier. But let me just, for when I do it, I would just write down what is f of 3, what is f of 1, and then do it. So remember, for this one I need to find f of 3 minus f of 1 all over 3 minus 1. So just to make sure, now at this point it can't go wrong. The only place that it can go wrong is you just do some numbers wrong. So I would just make sure that I get my numbers right. So f of x is equal to x squared minus 4x. So f of 3 is equal to 3 squared minus 4 times 3, which is, I don't know, 9 minus 12 is negative 3. And f of 1 is equal to 1 squared minus 4 times 1, that is 1 minus 4, which is negative 3 again. Okay, so what do you get here is f of 3 is negative 3 minus negative 3 over 3 minus 1. That's the average rate of change. And what you can see here is negative 3 minus 3 is negative 3 plus 3 over 2, but this is 0, 0 over 2, which is 0. So the average rate of change from 1 to 3 of this function is 0. Now, if you look at the graph of this function, what would you see? Well, in order to do that, you need to know how to draw the graph of the function. By this time, let's assume you don't, but just believe me when I say the graph is an inverted parabola that passes through 0 and 4. Oh, well, no, it is not an inverted parabola. It's just a parabola. So let me just draw it here. Sorry about that. So the graph is a parabola that passes through. So something like this, and f of 1 is negative 3, probably somewhere here. So negative 3, 1. And f of 3 is again negative 3. So you can see the average rate of change is the slope of this line. And it's a slope of a horizontal line. And what's the slope of a horizontal line? It's just 0. So we are looking at the slope of this line, which is just 0. This line right here. Okay. So find the equation of the secant line. So it's a horizontal line. Horizontal line has the equation of the form y equals constant. And it's passing through the point 0, negative 3. So that constant y is negative 3 because it would keep at negative 3 always. So the equation of the secant line is just y equals negative 3. in a way that this equation of the secant line example is not that satisfactory because we just found a horizontal line. So let's go to a question. The question is about average rate of change. So remember this formula right here, plug it in, and we will talk about a secant line. All right, let's do it. Okay, so I hope you got that right. The average rate of change ends up being 9. Okay, so let's see what it means graphically here. And I just messed up the graph, so I just thought, okay, let's teach this. So you have x-axis and y-axis, and x squared plus 3x would be a graph like this. It's a parabola. This point is -3, this point is 0. And you're looking at f of 4 minus f of 2. So f of 4 probably would be somewhere here, that's 4. And f of 2 probably somewhere here. This is not drawn to scale. Okay, so you are looking at the secant line. You are looking at this line right here. And that slope is equal to 9. Okay, so that is what we are looking for. And if I ask you this, so if I just wanted to make this harder and ask you what's the equation of the secant line, what you do is you would find a point, and one of those points, as you found here, is 4, 28, and use point slope formula. So point is 4, 28, because f of 4 equals 28 and slope is 9. So you get y minus 28 is equal to 9 times x minus 4. So y minus 28 is equal to 9x minus 36. So y equals 9x minus 8. That is the equation of this line. Alright guys, let's move on to the next one, which is odd and even functions. Again, there are shortcuts, so you don't have to worry about every single thing. You can just look at the shortcut, and the shortcut is every power odd. So if you look at for polynomials, if all the powers are odd, we have an odd function. If all the powers are even, we have an even function. So those are the two things. Alright, so right now, right here, you can see that x to the power 3 and 6x to the power 1, and both are odd. Therefore, the function is odd. Now, we are not going by the definition, we are just going by a shortcut, and I believe you like the shortcut better. Okay, and the second one, 3x4, x to the power 2, and 5, but 5 can be written as 5x to the power 0. And now you can see that it's even, even, and even. Well, 0 is an even number if you're thinking about that. Okay, it's between two odd numbers. So it's even, so all the powers are even, so this function is even. We can use this shortcut for polynomials only. So remember, it's very important that you apply this shortcut for polynomials only. Okay, so for non-polynomials, you will have to actually plug it in. I couldn't find a nice example. This one right here is not a good example, because what you can do is x4 plus x squared plus 4, and then you can just cross it off, right? And you get x to the power 4 plus x squared plus 4 over 1. And you can see this function is an even function, and you divide 1 by an even function, it ends up being even. And if you're not sure about that, what you need to do is plug in f of negative x. So this is how you actually check by definition. The definition says f of negative x, if f of negative x is equal to fx, you have the function to be even. So let's see, f of negative x, plug in negative x, you get negative x4 plus negative x squared plus 4, and negative and to the power 4, that should just be positive x4 plus positive x squared plus 4, and you can see that it's the original function. So with the definition we can say that the function is even. So in order to check the function is even, by definition, plug in negative x for x and see whether you get the same function. Now this is same as symmetric with respect to the y-axis. Alright, let's move on to a question, and then we will finish this off. Okay, so it was a very short video comparatively. Thank you very much. Okay, so that's it. You can see it's odd, odd, and even, because 0 is an even number, therefore the function is not odd. Alright.